This videotape will show you how to perform internal machining operations on the engine lathe with the tool held in the tailstock or the tool post. The operations you will see are drilling, boring, counterboring, and reaming. Drilling precedes the other operations and is usually done with the work held in the chuck and the drill in the tailstock spindle. Boring enlarges and trues an existing hole, generally removing about 1/32 to 1/16 inch of material. Counterboring also enlarges existing holes, using a pilot drill to align the tool on the center of the hole. This operation gives you a square shoulder at the bottom of the hole. Reaming quickly and accurately finishes an existing hole. It is performed either by hand with the work held stationary in a chuck and the tailstock used for alignment, or by machine reaming with the reamer held stationary in the tailstock and the work turning in a chuck. After viewing this videotape, you should be able to describe the safety procedures to observe in the shop and in performing drilling, boring, counterboring, and reaming operations. Describe the procedures for drilling on the lathe. Describe the procedures for boring and counterboring on the lathe. And describe the procedures for reaming on the lathe. When you are in the shop, you have to take some precautions to protect you and the people around you. Always wear safety glasses. Take off all jewelry such as rings and watches. Roll your sleeves above the elbow and make sure your clothes fit close enough to keep from getting caught in the machine. If you need to remove chips from a moving part, always use pliers. Never use your fingers to remove chips. Check the work set up by hand before you start the machine to be sure that all the parts are clear of each other. Take the chuck wrench out of the chuck before you engage the clutch. Never take your hand off the chuck wrench while it is in the chuck. To drill on a lathe, you begin by mounting the work in a chuck. Face the end smooth and square. A rough end may cause the drill to wander. The specified diameter for the hole is 1/2 inch, which we will drill in 3 steps. A center hole, which provides alignment, a lead hole, which prepares for final drilling, and the final drilling operation. To center drill the work, you mount a drill chuck in the tailstock spindle and secure a center drill in it with the chuck key. The center drill is a drill combined with a countersink. Use the largest diameter possible to get more rigidity and accuracy and prevent drill breakage. In this case, a number 5 with a 3/16 inch drill and a 7/16 inch overall diameter will be the best choice because the lead hole will be 1/4 inch. To complete the center drilling setup, calculate your spindle RPM. The work is machined steel with a cutting foot speed of 100 surface feet per minute. 4 times 100 divided by the drill diameter will give you the correct setting. In this case, the drill is 3/16 inches, which means 2100 RPMs, and the overall body diameter is 7/16 of an inch, which means 915 RPMs. So you select an RPM between the two, preferably on the high side. Too slow an RPM or too much feed pressure will break drills. Set the RPM at 1500. Move the tailstock until the drill is about 1 inch from the work. Engage the clutch. Apply a little cutting oil to the drill tip. Then you use the tailstock wheel to feed the drill into the piece. Drill until the countersink is approximately 1/4 inch across to match the 1/4 inch lead drill. Back the drill out. Move the tailstock back. And disengage the clutch. Now mount a 1/4 inch twist drill in the drill chuck for the lead drilling operation. Reset the spindle RPM, calculating for a 1/4 inch drill. Here the formula yields 1600 RPMs, so change the dial to the new speed. Move the tailstock until the drill is about 1 inch away from the work. Clamp the tailstock and engage the clutch, and apply cutting oil to the drill tip. Now use the hand wheel to feed the drill into the work at a slow, steady rate. Back the drill out occasionally to clear chips and re-oil the drill tip and hole. Drill the hole to the specified depth or clear through as you see here. The lead hole must be larger than the web of the large drill. When the lead hole is complete, back the drill out. Disengage the clutch and move the tailstock back. Next, you mount a 1/2 inch twist drill in the drill chuck and reset the spindle RPM. As you can see, the formula yields a setting of 800 RPM. Slower settings are necessary with larger drills to prevent burning and dulling the drill and marring the surface finish of the hole. Now clamp the tailstock in position. Engage the clutch. Lubricate the drill tip and hole. And use the hand wheel to feed the drill into the work. For the best surface finish, use a slow, steady feed that produces a thin, continuous chip. You have now drilled the hole to specifications. Move the tailstock back and disengage the clutch. Remove the drill from the drill chuck and remove the drill chuck from the tailstock spindle by cranking the hand wheel back until the shank releases from the taper in the spindle. Be sure to hold the chuck to keep it from falling. To drill holes larger than 1/2 inch, you use tapered shank drills that fit directly into the taper of the tailstock spindle. These drills have a tang which fits in a slot in the tailstock to keep them from turning. You can also use a lathe dog to help absorb the twisting force of heavy drilling operations. Here you see the dog holding a 1 3/4 inch drill. The RPM for this 1 3/4 inch drill is 228. Set the dial. Engage the clutch and drill the hole. Use the same steps for large diameters as for small ones. First center drilling, then lead drilling to ensure straight, accurate holes. Boring requires a hole for starting. In this case, we will use the hole drilled in the previous demonstration. Set up the boring bar in its holder to cut on the front or operator's side of the hole. There are various ways to hold the boring bar. In this case, you see a quick change tool post holder. Mount the tool bit into the boring bar. The bit should be ground as if it were to be used for straight turning. Set the tool point at center height of the hole. Extend the boring bar out of the holder just far enough to reach the depth required without hitting the chuck or the work. Tighten the tool and bar in place. Run the bar into the hole, letting it extend through the hole about 1/4 inch. Now turn the work by hand to check for clearance. Back the bar out. Set the RPM, using the same cutting speeds for boring as for straight turning. You will see a finishing operation on a 1 3/4 inch diameter. So 4 times 100 divided by 1 3/4 equals 228 RPMs. We will use a finish feed of 3 thousandths to 10 thousandths per revolution. Set the feed at 5 thousandths for a start. If you have a lot of material to remove, set up for roughing first, then take your finishing cuts. Engage the clutch and touch the bit to the work by hand. Move the tool out of the hole. The specified diameter is 1 812 thousandths, so you have 62 thousandths to machine off the diameter. Take a depth of cut of 15 thousandths, which will cut 30 thousandths from the diameter and leave 32 thousandths for a finished cut. Engage the feed and bore the hole. When the tool bit clears the back of the hole, disengage the clutch. Back the tool out of the hole. Do not move the crossfeed dial, since the depth of cut is set. Measure the hole diameter. The most accurate measurement can be performed with a telescoping gauge and outside micrometer. This hole measures 1 782 thousandths, so our finish cut will remove 30 thousandths from the diameter. Take a depth of cut of 15 thousandths on the crossfeed. Engage the clutch and feed lever and bore the hole. When the cut is finished, you move the tool bit in to clear the hole surface and remove it from the hole. Measure the work for size. This piece measures 1 813 thousandths, which is within tolerance, so the boring operation is complete. You can use counterboring for recessing a hole to a given depth or for roughing out a hole for single point boring. This counterbore is made to be used with a pilot. The pilot ensures that the pilot hole and counterbore hole will be concentric. You will need a pilot hole 2 thousandths to 3 thousandths larger than the pilot before you can counterbore. If the pilot hole is not slightly larger, the pilot will bind and break off. Set the RPM and drill the pilot hole using the center drill. Lead drill and pilot hole drill. If the pilot is smaller than 1/4 inch, you will not need a lead hole. You will usually mount the counterbore in a drill chuck held in the tailstock. Set the RPM by calculating or using a chart. Touch the counterbore to the end of the work. When the tool touches, tap the tailstock by hand until you have an inch showing on the spindle markers. Clamp the tailstock in place. The specified depth of this counterboring operation is 1/2 inch, which you can measure on the tailstock spindle markers. Before you take your cut, back the counterbore out. Engage the clutch and lubricate the hole. Using the tailstock hand wheel to feed the counterbore, take your cut to a depth of 1/2 inch. Back the counterbore out. Move the tailstock back and disengage the clutch. Check the hole with a depth rule. And this counterboring operation is complete. Reaming is a way to quickly and accurately finish drill or bore holes to size. You will see two methods: hand reaming and machine reaming. Hand reaming operations are performed with the work held in a chuck and the spindle locked or in a low RPM. The reamer is supported by a tailstock center and turned with a tap wrench or adjustable wrench. Hand reamers are designed to remove no more than 3 to 5 thousandths of an inch from the diameter. This workpiece has been drilled and bored to 995 thousandths, and we will ream it to a specified diameter of 1 inch. Insert the reamer into the hole and support it with a tailstock center. Apply a little oil to the reamer and in the hole. Now turn the reamer clockwise, applying slight pressure to the tailstock to force the reamer into the work. When the reamer has cleared the back of the hole by about 2 inches, back the tailstock out of the way. Turning the reamer clockwise, pull it out of the hole. Never turn a reamer counterclockwise, because it will dull the cutting edges. Here you see a very useful type of hand reamer. It can be adjusted to any diameter within its specified size. Set it to diameter with a micrometer, and then use it in the same way as a straight hand reamer. Machine reamers are generally held in a drill chuck in the tailstock and fed into the work rotating in a chuck. Machine reamers can remove more metal than hand reamers. You normally leave 10 thousandths to 15 thousandths for machine reaming. This piece has been drilled to 47/64, leaving 1/64 or 15 thousandths for reaming to a specified diameter of 3/4 inch. Place the 3/4 inch reamer in the drill chuck. The cutting foot speed for machine reaming is 50 surface feet per minute for soft machine steel. So 4 times 50 divided by 3/4 inch equals 260 RPMs. Speeds for this operation are much slower than those for straight turning or boring with soft machine steel. Set the RPM. Engage the clutch. And move the tailstock until the reamer is about 1 inch from the work. Clamp the tailstock. Oil the reamer and the hole. And feed the reamer into the hole with a tailstock hand wheel. Use a feed rate of 8 thousandths to 15 thousandths per revolution. Feed the reamer in until it extends past the work by about 1/2 inch. Remove the reamer. Never reverse the machine during this operation, because that will dull the cutting edges. Shut off the machine. You have now seen the procedure for machine reaming. To review briefly, you should now be able to describe shop safety procedures for drilling, boring, counterboring, and reaming operations. Describe the procedures for drilling on the lathe. Describe the procedures for boring and counterboring on the lathe. And describe the procedures for reaming on the lathe. You have now been shown 4 common internal machining operations for machining holes in a workpiece to an accurate dimension.